Okay, guys, so we have a conservation of energy problem for a roller coaster. So how this one works is there's a couple little things you need. Okay, you need to know that at the top of the roller coaster, the speed is 0, and therefore the kinetic energy will be 0. And then another thing you'll need to know is once you know the total mechanical energy, all right, once you find the mechanical energy at one point, all right, for a closed system like this, that energy is going to be the same for throughout the entire thing. It's the same throughout. So we have our equations here. So right off rip, if you look at position 1, they give us a mass. Okay, so you know right off the rip, right before the roller coaster goes down, it's dive. They usually kind of pause it to kind of build up the anticipation, scare you a little bit, and then drop. So we have a velocity to 0 there. Cool. Do we have a mass? Yes, we do. Do we have a height here? Yes, we do. So potential energy is mass times gravity times height. So you would do 50 times 10 for the mass. Or I use 10 for gravity. If you use 9.8, you use 9.8. And then 4 for our height. So when you multiply all that out, you're going to get 2,000 joules. So the potential energy at the top here is 2,000 joules. If the velocity here is 0, it doesn't matter that you have a mass of 50, 1/2, all right, 50 times 0 squared. Kinetic energy is going to be 0 joules. And very, very simplistically, mechanical energy is the potential energy and kinetic energy at that point. So if the potential here is 2,000 and the kinetic is 0, all right, you add those together. So the total mechanical energy at any one of these points that are listed is going to be 2,000 joules. All right, we don't need to do velocity here because kinetic energy is 0, so the velocity is 0 meters per second. Okay, well at point 2, they don't give us a velocity, so we're kind of chilling on that for a second. But they do tell us enough information, right? We know what the height is. The height is now 3 meters. The mass is still the same. The mass of the roller coaster didn't change, so this one is going to be 50 times 10 times 3. And this comes out to be 1,500 joules. So we have a potential energy here of 1,500 joules. Once we have that kinetic energy, well, we don't have velocity, so we can't solve for it there. Thank you. But what we do know is that the mechanical energy, all right, is the same at every single point. So I don't even need to do math for this. I just know that it's going to be 2,000 joules here and at every single other point. So we can just fill those in real quick. So only at the top, all right? They're not always going to be equal. So you see here at point 2, it's not 2,000, it's 1,500. All right, and why? Well, because at the top, think about it, the roller coaster is not, it's just chilling, right? It's not moving. And then it's like going to freak you out for a second, and then it's going to start to drop. So then it's dropping, it goes, and right here at point 2, it's moving. So there is going to be some of this energy, it's going to be kinetic. Now, we got to try and figure that out, but we don't know, they didn't give us a velocity. We still know the mass is 50, but we don't have V. So if you look at this, though, we just know that, all right, so I kind of basically said at the top for these kind of problems.
Oh, okay.
The roller coaster at the top is 0. So here, we don't have velocity for point 2, but what we do know is that the mechanical energy is 2,000. Excuse me. And now mechanical energy is potential plus kinetic. No matter what, once you know what it is at one point, it's the same throughout the whole thing. So if we know that it's going to be 2,000, and we know potential is 1,500, what would kinetic energy have to be in order for mechanical to be 200, right? So I'm just going to reverse this. If you know one of these or two of these, you can find the missing. So I know mechanical energy is 2,000. So what I would do is I would show it like, okay, well, if I'm looking for kinetic energy, it would be mechanical energy minus the potential. So it would be 2,000 minus 1,500. So the kinetic energy would be 500 joules.
What would be the mechanical energy? That would be 1,500? What would be the mechanical?
Mechanical energy is still 2,000. Mechanical energy is still 2,000.
And the potential is?
No, the potential for point 2 is 1,500. So basically, if we know that this is going to be 2,000, and we had enough information to find this, you just do a simple subtraction. Okay, so now we can actually do the velocity here. All right, the equation up top, 2 times the kinetic energy. So our kinetic energy for point 2 we just found is 500. So you would do 2 times 500 divided by the mass. The mass at the top of the problem was 50 kilograms, so that doesn't change, right? So m is here in the equation, so 50. And then you square root that to find velocity. And this comes out to be 4.47 meters per second. Now, the assignment that we're doing tomorrow is going to be basically kind of a you remember when we did the projectile motion thing with the clues, trying to figure out who the suspect was? It's going to be something similar to that. There's going to be different stations that you need to solve correctly, and from there, all right, it's going to give you enough information to move to a next thing. And then at the very, very end, you should have enough information to kind of solve for the missing or the final clue, final piece. And then we'll do a thing, guys, tomorrow where the winning team, get like a little prize. Yes, sir.
Can you show me that last part again? Because I did that formula, but I got
This right here. All right, so do 2 times 500. It's 1,000, right? So 1,000 divided by 50, which is 20, and then you square root that number.
Oh, okay.
All right. And then you got your 4.47. Yeah.
All right, yeah, I got it.
Okay. Now, if we go back to the picture at point 3, we don't have a height, we don't have a velocity. So what's up? Well, guess what? Where does the position look like? Where does the height look like it is? It's at 0. That's good. Take this roller coaster piece right here, and we're going through this right now. So if we know right at point 3, there's no velocity given, but it looks like where it's on the ground. So if it's on the ground, what do you think the height would be? Bet. Very good. Now, if the height is 0, what is potential energy going to be? Right? Mass times gravity times height. Anything times 0 is 0. Now, you don't need to show the work for that one because you should know. Okay. Well, then what the heck does the kinetic energy have to be? It has to be 2,000 because potential plus kinetic at any given point, right, whether it's 1, 2, 3, 4, it has to add up to this 2,000. So really, I mean, you could show, 2,000 minus 0, but Bam, kinetic energy, 2,000 joules. Okay, so now what? Now what do we got to do? Well, now we can find the velocity, yeah? You got to do 2 times kinetic energy with 2,000 divided by the mass of 50, and then square root it. So 2 times 2,000 divided by 50, and raise it to, or find the square root of that, and you get 8.94 meters per second. Now, do you guys think, should that be the fastest point? You think at 3 it's technically the fastest, or would it like be like somewhere over here in the squiggles? Well, all right, for these problems, all right, for this level of physics, all right, when all the energy is kinetic and potential 0, it's going to be the fastest. So technically, the only other spot where it could be technically the fastest would be there and over here. Those aren't any of the spots we're looking for. So 3, all right, is yes going to be the fastest one that we have. It's 2,000. Once you found it at the one spot, it never changes. Guys, shh. Okay, so the last one. What do we got for the last one? At point 4, we don't have a height. So we can't find potential energy right away, right? Because, I mean, even though we know the mass and gravity, we don't know what the height is, so that's kind of cheeks. Now, what we can do, though, is if you have velocity and mass, now we can find kinetic energy. So the velocity here is 6, and the equation for kinetic energy is, right, the 1/2 mv squared. You're only squaring the velocity. So 1/2 times 50 times, it's 6 squared. All right, so 6 squared is 36 times half of 50 should give us 900 joules, I believe. Yep. Okay, so we know if this is 900 and this here is 2,000, and we look at the equation, the mechanical energy is potential plus kinetic. So what plus 900 is going to give me 2,000? Yeah, 1,100 joules. Okay, now if you wanted to show that, you could just say, again, all right, the potential energy here can be mechanical minus kinetic. So your 2,000 minus 900. And that's where we get this guy here from. All right, well, now we got to find the height. How the heck do we find height? Well, remember our triangle for potential energy. PE's on top. M times G times H on the bottom. Now, if we want to solve for H, cover it up in the triangle. And what does it tell us to do? Well, PE's on top, so H will equal PE divided by, now since they're next to each other, you multiply, so divided by M times G. Okay, what was our PE that we found? 1,100. And then mass of this thing was 50, and gravity we're using 10. So we should have 1,100 divided by 50 times 10, and we should get a height of 2.2 meters. Bing, bang, boom. Bing, bong. Okay, so here is the overall scale, right? Again, right? So key points that you guys need to know for your test for Friday, all right, when you get a problem like this at the top, right, for these problems that we're doing, unless specified otherwise, the velocity is going to be 0, the speed 0. So that means at the very top, all the energy is potential, right? 2,000. And so if kinetic is 0, whatever your potential plus kinetic is, that's mechanical. Then once you find mechanical energy at one point, it's the same for every others. And then you should have enough information to figure out one of these two, all right, for a roller coaster problem, and then do a kind of a subtraction. Okay, and then from there, if you need to find the speed or velocity at any of those points, okay, that would be how you do it. Velocity, height. Okay. So those are like the key points. All right, these are the answers that are boxed in. Does that help? Hope that helps. You guys good with that? Smooth? Okay. Excellent, excellent, excellent.